let's see this order of an element of a group. Order, we have already seen this term order earlier. That was when we are talking about the finite groups. Order of a group is nothing but the number of elements in the group, but here order of an element, we are not talking about the entire group, we are talking about an element. And mostly we will be applying order of an element in a finite group. It is not that we cannot apply for infinite group, but then we generally apply it for finite groups. Later we shall go for infinite groups also, but just see this one. I'll take an example and explain you. Let us say we have this finite group, right? Let me take this finite group 1 comma minus 1 are the elements in this set, and with respect to the operation multiplication, this is a group, isn't it? It is a finite group because the number of elements are finite, right? Now what is the identity element? Identity element is 1. If you take any other element and if you keep on raising it to some power, which means if you keep on applying the operator with itself, then at some point we will get the identity element, right? So which means if I take the element 1 power 1 is 1 directly, but then if you take the element minus 1, if I apply it with the operation 2 times, then I am going to get 1, which means minus 1 power 2 is equal to 1. Therefore order of minus 1 equal to 2. That is what the meaning of an order. So what is an order? If you have a group, then you will have a identity element. Now if you take an element and if you raise it to some power, then you are going to get the identity element. Then smallest such number is called as order. So for example, order of minus 1 is 2, but then you can even find out that minus 1 power 5 is also equal to identity element 1. You cannot say that order of minus 1 is 4. The reason is order is applicable only for the smallest integer, which means what is the smallest integer at whose power you are going to get the identity element. Got it? And what about the identity element itself? Order of the identity element 1 is 1 itself, because 1 power 1 we got 1, that is why this. Let's take one more example. See this. Let me take one more finite group. Cube roots of unity 1 omega square. This is the cube roots of unity, right? With respect to multiplication, again it is a finite group. Then in this finite group, what is the identity element? Identity element I equal to 1. If you take all the elements and if you keep on raising them to the power of n, at some point you are going to get the identity element. For example, for 1 power 1 is going to be 1. Therefore order of the element 1 is 1. So always remember this point. Always order of identity element is 1 in any group. Finite or infinite, it doesn't matter. Always order of identity element is 1, right? So what about omega? See this, omega power 1, omega power 2, omega power 3. So omega power 3 equal to 1. It means that omega, when I apply it 3 times, then I am going to get 1. Therefore order of the element omega is 3. Order of the element omega is 3. Got it? And then similarly you can see what is the order of omega square. So omega square, if you want to get, if you raise it to the power 3, then you are going to get 1. How? Omega, you can write this one as this, and it is nothing but 1 square, which is nothing but 1. So the smallest integer to which you have to raise omega square to get 1 is 3. Therefore order of omega square is also 3, right? So order of omega square is also 3. Order of omega is also 3, and order of 1 is 1. Got it? So this is about the order of an element. So we are talking about the order of the element. Now what is the order of the group? Order of the group is number of elements present in the group. Now what is order of G? Order of G in this case is 3, right? So there will be one interesting property here. Always order of any element will always divide the order of the group, right? And we can apply this only for the finite groups, because for infinite groups we cannot have order of the group. Only for finite groups we can have a finite number as order of the group. So remember this, order of any element will always divide order of a group. Got it? So order of some, any element is going to divide it. In this case also, what is the order of -1? 2. What is the order of the group? Order of the group here is 2. Therefore it divides it. Now just see the definition so that you will understand it better. Let capital G comma star be a group and an element A belongs to G, then order of the element A is the smallest positive integer n such that A power n is identity element. Important point is smallest positive integer, because for many integers we'll get A power n as I, but then we want to take the smallest such number. In this case A power 3 is going to be 1 omega power 3 is going to be 1, as well as omega power 6 is also going to be 1, but then order is not going to be 6, order is 3, the smallest integer, smallest among them we are going to take. Now we can take one more example if you want. Let us say 0 to n minus 1 and then addition modulo m. 0, 1, 2, let's say these are the elements of this set, and then addition modulo 3 is the operation, then it is going to be a group. Now in this group you have the identity element. What is the identity element for addition? It is always 0, therefore identity element is 0. So what is the order that you have to of each element? That is what we have to find out. Now 0 power 1 equal to 0, therefore order of the element 0 is 1. Okay, it is always there. Order of the identity element is always 1. What about order of the element 1? Now if I take 1 and if I apply the addition modulo 3, we get 2, right? If I take 1, which means it is not identity element. If I take 1 and if I apply addition modulo like this, then we are going to get 0. 1 plus 1 plus 1 is 3, and 3 when divided by 3, remainder is 0. Therefore you can write this one as, even though it is addition, you can write this one like this: 1 power 3 equal to 0, right? Why? Because in this group, when I talk about the power, it is not multiplication, it is the operation under which this group is defined, which means when I write 1 cube, it is actually this expression, right? So you should not think that it is multiplication, it is the operation under which this group is defined. Okay, so 1 cube is 3. So what can we say? We can say that order of 1 is equal to 3. What about 2? You can try to find out the order, right? So 2, it is going to be 1. The reason is 2 plus 2 is 4, and 4 when divided by 3, the remainder is going to be 1, right? And then 2, if I do it 3 times, which means this is going to be 1, because 0, because 2 plus 2 plus 2 is 6, 6 when divided by 3 is, remainder is 0. So what can we say? It is 2 cube is equal to 0, which means order of the element 2 is 3. Got it? So what is the order of the group? Order of the group itself is 3, because the number of elements are 3, and every order of every element divides that. Okay, remember that point. And one more interesting thing is, if it is a group, then we know that every element is going to have an inverse, right? Order of A and order of A inverse, both are going to be same. Just see this one. In this, what is the inverse of 1? Inverse of 1 is 1 itself. And what is inverse of minus 1? It is minus 1 itself. So we cannot do anything there. Okay, let's see here. What is inverse of omega? Inverse of omega is omega square, and inverse of omega square is omega. Therefore both omega and omega square are supposed to have the same order, and in this case it is true, isn't it? Order of omega is 3 and order of omega square is also 3. Therefore remember this: order of an element and order of its inverse, both are going to be same. If you find out the order of A, you need not find out the order of A inverse, it will be same. Here also you can check it. What is the inverse of 1 in this case? Inverse of 1 is 2, right? Because if you apply this operation between 1 and 2, you are going to get the identity element 0. Therefore 1 and 2 are inverses of each other, and order of 1 is 3 and order of 2 is also 3. Got it? So you can remember this: order of A and A inverse, both are going to be always same. Okay, so we can see more problems on this, you will understand it better. Fine. if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.